In 6.3 we learned a little bit just about how to graph polar coordinates and just kind of to set up the relationships. Today we're going to work with those. Okay, so we're going to spend on 1 and 2 going back and forth between, if you're given one type of coordinate, how to get to the other coordinate. So how to use those conversions or those relationships were provided. So on number 1, there's an A and a B here essentially. So the polar coordinates of, and the first point given is that 5 comma pi over 6. We're being asked to find the rectangular coordinates. Okay, so if we're trying to find the rectangular coordinates, we're trying to find what? X and Y. Okay, what are we given? 5 and pi over 6, which are r and theta. Okay, plug them into some equations here. Okay, if we know r is 5 and theta is pi over 6, what equation do you want to use? Which x and y? I've got 4 different conversion options here.
The first x equals and y. 5 cosine pi over 6.
Okay, so start with x equals r cosine theta, because we know r and we know theta. And I'm just, I'm being nitpicky here because all of these equations have some combination of x and y, don't they? Okay, so I'm going to call this example A, if you will. And so example A, we are going to start with x equals r cosine theta. And as we start with x equals r cosine theta and plug in the points. So r is 5, and we're doing cosine of pi over 6. Your go-to should always be, don't pick up that calculator until it's something you can't do without the calculator, if that makes sense. As in, cosine of pi over 6. Pi over 6 is one of our known reference angles, isn't it? Okay, so don't go straight to the calculator. Let's use what we know. So what is cosine of pi over 6?
1/2.
Disagree.
Square root of 3 over 2.
I like that answer better.
Wrong one.
Okay. So 5 times square root of 3 over 2, because cosine of pi over 6 is square root of 3 over 2. And let's see. I guess I have it in both forms in my notes. I think just for kind of graphing purposes, references purposes. But what is 5 times square root of 3 over 2? 5 square root of 3 over 2 is, in my brain, ideally what you should be saying there. Now, is there a decimal answer there also? There is. What is the decimal answer?
4.3.
Okay. What's 2 decimal places?
4.33.
4.33. Now, here's the deal. When I give my ordered pair here in the moment in the final answer, I'm going to use that 5 square root of 3 over 2. But when we do kind of a mental check to make sure we landed in the right quadrant, that 4.33 is helpful. Okay? So, now we have x. What else do we need to find? Y. So I'm going to use the formula y equals r sine theta. Fill in your information. Y equals 5 times sine of pi over 6. What is sine times pi over 6? There's the 1/2.
Yeah.
And what is 5 times 1/2?
2.5. 2.
5 over 2.
Okay. My preference would be 5/2 in this situation. However, that's also one that you can do without a calculator and very easily get to 2.5.
Yeah.
Okay, so, but if we're trying to keep it in the form of the last one, I'm going to go for the fraction. Now, with this, I'm running out of room here, but, okay. So the answer, since it said for rectangular coordinates, the answer I would give would be 5 square root of 3 over 2, comma, 5/2. Now, real quick question. Logically, graphically, does this make sense?
Yeah.
So if we think about the graph of this, okay, where would 5 comma pi over 6 be?
Quadrant 1.
Quadrant 1, because pi over 6 is something right here, yes? Might be a little bit low, but you get, you know. Pi over 6 is here, and then going out 5, just, I'm picking a random spot there. Does that make sense with the ordered pair I just got?
Yes.
The ordered pair I just got, this is where it's helpful to look at the 4.33, isn't it? Well, I don't know 5 squared root of 3 over 2 what that is, but 4.33 comma 2.5 would be over 4.3 up 2.5. Does that make sense?
It is.
Okay. And that should, you know, logically make sense. Okay. Shall we try what I'm going to call B? Actually, it's already called B now that I look at it.
Same thing.
Okay. She says same thing. We're trying to take -6 comma negative pi over 2 and convert it to regular or rectangular coordinates. What do we know about -6 and negative pi over 2?
They have a positive.
7.
What are these pieces?
R and theta.
R and theta. Now, some of you are already kind of thinking about where this is going to land, isn't it? And I'll tell you, and I can tell you now, I'm going to tell you in the end, but you could do this one without your formulas. Okay? You could do this one without your formulas. Just by plotting this r comma theta
0.
and figuring out what it's going to be in terms of x, y. Now, I'm going to demonstrate using our formulas, but then I'll talk about that. And then, so our formulas, can we do this one the same way as last time? Yeah. The fact that we can use x equals r cosine theta. So x equals -6 times cosine of negative pi over 2. Well, that's -6 times something. Where is negative pi over 2?
Oh, it's down. On the
Like positive.
Because going up would be, and I'm going to erase this, I'm not leaving this here, this is just your diagram to help you remember, but going up is positive pi over 2, that's positive 90, yes? Negative pi over 2 takes you down, I heard positive 3 pi over 2, that's equivalent there, 270. So we're right here. What is cosine at this angle?
0.
Cosine is 0 because the ordered pair is 0, -1, yes? And in an ordered pair it is cosine sine. Coming back to us? So we can agree that cosine of negative pi over 2 is 0. Which actually, if you goofed up, cosine of positive pi over 2 is also 0. So if you goofed up and did that one, you got 0 both ways. Okay, what is -6 times 0? 0. Okay, so we have an x coordinate of 0. Let's figure out our y coordinate. Y equals r sine theta. -6 times sine of negative pi over 2. -6 times -1. Glad I didn't erase it yet, right? -1. Maybe I should have put this up here so we could have it somewhere. What are we doing about -6 times -1?
Y.
Y equals 6. Okay. Now, first of all, ordered pair here is 0, 6, yes? I want to talk about, logically, -6, negative pi over 2. How do we graph -6, negative pi over 2? Negative pi over 2 says we go down to here, yes? So we're on this angle, which is negative pi over 2. What does negative 6 say we do?
Yeah.
You go backwards through the pole, and so negative 6 is actually going to end up here up at positive 6, yes? Does this make sense with the ordered pair 0, 6? Yeah, 0, 6 is left to right 0, up 6. So that should make sense. Okay? Now, with that information, could you have done this one without using your formulas? Technically, yes. Because once you realize that, oh, negative pi over 2 is one of my axes, you know where you can figure out rectangular coordinate-wise. It's just realizing that, okay, down 6 would take me up 6 here, so we end up with that piece. So it is possible to do that without that one without your formulas. Not going to argue the same on part A, but I can on part B. Okay?
Bless you.
Questions here? Okay. Now, let's try number 2. Number 2, we've got to reverse it. We've got to go the other way. They are providing us the rectangular coordinates. We need to find the polar coordinates. So they are providing me x and y. We need to find r and theta.
Plug it into the r squared equation.
Okay. So realize we're using the other equations this time, yes? Okay, so I'm calling this again example A. And so if we start with r squared equals x squared plus y squared, r squared equals negative square root of 3 over 2 quantity squared plus y squared 1/2 quantity squared. Again, don't rely on the calculator here. Use your brains. You got them. You're given them for a reason. Use them.
3 over 4.
Okay. Negative square root of 3 over 2. The negative squared becomes positive. The square root of 3 squared becomes 3. And the 2 squared becomes 4. So that is 3/4. 1/2 squared. 1/2 times 1/2, which is 1/4. So we end up with r squared equals what? 1. If r squared equals 1, what do you know about r? It's the square root of 1, which is?
Isn't it?
What?
Plus or minus.
Plus or minus 1? Yes, the square root of 1 is 1, but don't forget that it's going to be plus or minus 1. Okay. So, yes, you should have 2. They are both correct. Okay, they're both correct. So hold those onto those. We'll come back and deal with those here in a little bit. What's the other piece of this we need to do? We need to find theta. And we know tangent of theta is equal to y over x. So tangent of theta is equal to 1/2 divided by negative square root of 3 over 2.
Tangent inverse.
Don't go there right now. I mean, yes, but hold that thought. Because I'm afraid when you guys say tangent inverse, you're automatically going to grab the calculator. So we're not going to go calculators. Okay? Now, what do you know about this fraction divided by this fraction? Okay. So both options work. We can multiply by the reciprocal, yes. When you do 1 over 2 times negative of 2 over square root of 3, what's going to cancel? The 2's. We could also multiply numerator and denominator by 2. So multiplying by 2 over 2. Guess what? Same result in that this fraction is going to clean up to be negative 1 over square root of 3. Are you with me there? Both options work. Now, negative 1 over square root of 3. What's a better version of that that should look familiar to us? Okay, so this is, we got to keep negative, but it is square root of 3 over 3 if we rationalize it, yes? Okay, and I guess we do have both versions up on our chart there, but my brain automatically says, okay, where is, rationalize that, so multiply by square root of 3 over the square root of 3. So we're looking for when does tangent equal negative square root of 3 over 3. Now, with that in mind, okay, Kylie mentioned tangent inverse. Officially, this is tangent inverse, but I'm not going to plug it in the calculator to get that. Okay, I want us to use our brains. And so we are asking ourselves, at what angle does tangent equal negative square root of 3 over 3? And I decide the best way to go about this. What's your brain have to think? No, I wouldn't. Okay. I mean, if we just look at when does tangent, and I guess where my brain would go here, on a side note, is my brain would briefly think, where does tangent equal positive square root of 3 over 3? And that is, according to our chart, the pi over 6, yes? Now, is pi over 6 what I need? I need the negative. So now we have to think what quadrants? Okay, pi over 6 is your quadrant 1 answer. What quadrants do I need? 2 and 4. Okay, not our positive quadrants. So, what angles do we need? In quadrant 2, what is my pi over 6 angle? What is the angle that's happening right before pi? And that is 5 pi over 6. Where do I have it expressed here? Okay. What's the other angle I need?
11 pi over 6.
Okay. Could we say 11 pi over 6 in quadrant 4? Yes. I'm trying to remember. Well, I have 11 pi over 6 kind of in parentheses. I think the answer key leans towards a different version of 11 pi over 6. What would be another name for 11 pi over 6?
Negative pi over 6.
Negative pi over 6. Okay. And so I have those two. Now, and again, here's the deal, guys. I need to go back and look because I honestly don't remember from previous. Negative pi over 6, I agree, and I'm not going to argue. This is 11 pi over 6, yes? Okay, that is equivalent. I need to go back. I don't remember, honestly, off the top of my head, why I went the direction of negative pi over 6. It's escaping me right now. Okay, but I do feel like that's what you would be more likely to see in the answer key. So remind me, I'll go back and check that out in a little bit. Now, okay, here's the deal, guys. Our job was to find the polar coordinates, yes? I found 2 r values and 2 theta values. You can't just stop here. We want polar coordinates. I need ordered pairs. So we have to pair these up. And we have to pair them up correctly. So in other words, our r value of positive 1 goes either with 5 pi over 6 or negative pi over 6. The r value of negative 1 goes with the other one. In other words, there are 2 correct matches that we can use here. And we have to get them to pair up correctly. Now, here's what I'm going to suggest that you think. So earlier, I had us do this as a check, yes? Now it's more of a required. Where is our original rectangular coordinate? Negative square root of 3 over 2, and then
Part 2.
positive 1/2 puts me in quadrant 2, yes? So here's the deal. I need to pair up my polar coordinates so they give me that point that I just put on my graph.
-1, 5 over 6.
She is suggesting, and I'll be honest, I haven't looked here to see if she's right, -1 and 5 pi over 6.
So you go like -1 and 5 over 6.
Because then you're backtracking.
I don't know, Mario. It was a guess.
I think I have to disagree with this
Why don't
guess.
you guess next time, man?
Now, okay, analyze, guys. Stop, analyze. Okay? Remember with polar coordinates, what do we graph first? We go the angle, yes? So where is 5 pi over 6? 5 pi over 6 is right here. What does -1 tell me to do, though? -1 would tell me to go back here. Is that what I want? No, that's not what I want. So instead of -1 5 pi over 6, what should I have there?
-1.
That's what
We have to get them both. So I was going to go the route of +1, positive 5 pi over 6. And here's the deal. We have to get them both, right? So if you thought about the other match, you're fine. Now, does this one make sense? 5 pi over 6 is quadrant 1 here. Going out 1 puts me right there, yes? Okay, process of elimination. What's my other pair? -1 and negative pi over 6. Does this pair match? So negative pi over 6 tells me to go down here, yes? So if negative pi over 6 lands me on this angle, where's -1 take me, though? Backwards through the pole and lands me in quadrant 2.
I don't like graphing. I would have been right if it was a regular graph. I didn't think about it.
Okay, so here's what I need you guys to do. Once you hit that point, you have to think. Okay? Up here, we didn't really have to do the check. It was just kind of, I thought, getting you in the right mindset. Here, we have to do this to figure out how they pair up. Because if you pair them up the other way, I can't give you full credit. Fair enough? Okay. We have another one to do, yes? Okay. Part B. -3, 0. And these were stated to be rectangular coordinates. So that means -3 and 0 are x and y. What are we doing? Okay, we can start with what looks like the Pythagorean theorem, yes. So r squared equals x squared plus y squared. R squared equals -3 squared plus 0 squared. R squared is 9. So what's r?
Plus or minus.
Plus or minus 3. You have to give both. Yes, because here's the deal, guys. Anytime you guys go from rectangular to polar, you're going to have two answers. We also need to think about tangent, yes? Tangent of theta is y over x. So tangent of theta is 0 over -3. So we want to know, when does tangent equal 0? I just realized, if I look at my notes, I'm doing this the difficult way.
No, we've already started.
That's
So basically, continue.
Okay. And here's my, my thoughts here are, I'm doing this a difficult way because we could have just graphed this. When I glanced at my notes here, that's what I did, is I just graphed it. I didn't go through the formula solving here. So, when does tangent equal 0? And then here's the deal. We don't have that on our charts, right?
So it'll be
What is tangent as a fraction?
Y over X.
Y over X or sine over cosine? So could we think about when does sine equal 0? Does that make sense? When I ask when does tangent equal 0, and we know tangent is sine over cosine. Here. Side note here. Tangent, you guys have known, this should be memory. Tangent is sine over cosine, yes? So if we're trying to figure out when tangent is 0, well, then what's that mean? 0 over some number. So we need to know when is sine 0. Okay? So if we go back to what we were doing earlier, let's see. 1, 0, 0, 1, negative 1, 0, negative 1. When is sine 0?
And 3 pi over 2.
When is sine 0?
2 pi. No. Yeah. No, you're right. Minus 1. Yeah.
So sine is 0. What I'm going to say is 0 and pi. Now, 2 pi I agree with, but when we give answers, we go on the first go round, and 2 pi starts the second go round.
Yes.
Okay? So theta is 0 and pi. Are you with me?
I was a little confused because they were not saying the same thing.
They were not, which is why I was repeating, when does sine equal 0? So, okay, guys. Now, we've got to put this all together. The original ordered pair was negative 3, 0 in rectangular. How do you graph negative 3, 0 in rectangular?
It would be on the x-axis. 3 over left, like 3.
There is our rectangular coordinate point, yes? Not to be confused with the polar coordinate point. Now, I need to figure out what this is in polar coordinates. How do I pair up my positive 3 and negative 3 with my 0 and my pi? And my brain says, okay, what angle am I on here? I'm on pi, yes. How far did we go out on pi? What's negative 3 do in polar coordinates?
Back, so 3.
Okay. So polar coordinates here, how do we feel about 3 comma pi?
You grab pi first.
Because even though it's r theta, you graph pi. So pi is over here, right? Here's pi. A positive 3 on pi says we go out 3. Even though, yes, we just went left, it's not rectangular. We didn't just go left. We went out 3 on the angle of pi. Okay. Now, what's that mean my other ordered pair needs to be? Negative 3, 0. Where's 0? 0's over here. What does going negative 3 on 0 mean? You shoot back through the pole, and you end up over here. Okay. Now, be careful, guys. Yes, this polar coordinate ended up being identical to the rectangular coordinate. Not always the case. You have to be very careful there. Okay? So again, important to look at the graph there. Okay. We have one more thing we need to look at. And that is number 5. Okay? Are we good on this one? This is stuff that's going to take some practice and homework, okay? So make sure you really focus on how to do these. Now, let's see, I'm going to pull this screen down a little bit. Because in order to do number 5, we have to have the distance formula. Okay. So number 5 asks us to compute the distance between these 2 points. And what are these points in? These are polar coordinates, aren't they? So these are r and theta values. Okay. Now, distance formula. These are 2 points. Okay. If we are in rectangular coordinates, we have a distance formula, yes. You remember anything about that distance formula? Square root
X Y2 squared.
Oh, never mind. Was there something
No.
on the right track, but slight variations here. Okay, so officially distance formula, square root, and this is for rectangular coordinates. We're getting ready to do polar coordinates. So rectangular coordinates is square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Yeah, you were mixing. I mean, I knew you were thinking about the right thing. It just wasn't quite there. Now, our distance formula for polar coordinates. D equals, well, here's the one thing that's similar. It's a big old long square root. However, R1 squared plus R2 squared minus 2 times R1 times R2 times cosine of theta 1 minus theta 2.
The most complicated thing in existence.
Nah,
Honestly.
this is not the most complicated thing in existence. Now, of course, this is based on having 2 ordered pairs, R1, theta 1, and, of course, then R2, theta 2. Does the inside of this formula look at all familiar to you?
No.
Yes.
Sure.
We replace those with, like, A's and B's. I don't know if you guys remember.
Yeah.
You guys remember law of cosines? Now, law of cosines, we never used r's and thetas, did we? It was A, B, and C. However, the law of cosines for this would be d squared equals r1 squared plus r2 squared minus 2 r1 r2 cosine of theta 1 minus theta 2. Oops. So that is where this distance formula comes from. Okay, shall we try and apply it? Okay, we have our 2 ordered pairs here. Now with these 2 ordered pairs, I called them r and theta already, but they are going to be what? r1 theta 1 and r2 theta 2, yes? Well, let's fill in our formula. Let's not waste any time here. D equals square root of r1 squared (2 squared) plus r2 squared, 4 squared, minus 2 times r1, which is 2, times r2, which is 4, times cosine of theta 1 minus theta 2, so 5 pi over 6 minus pi over 6. Okay, let's do some cleanup. What do you know about 2 squared?
4
4 squared?
plus 16 is 20.
And so 4 plus 16 is 20. Minus, what do you know about 2 times 2 times 4? 16. Times cosine of, what do you know about 5 pi over 6 minus pi over 6? 4 pi over 6, which becomes 2 pi over 3. That was some good cleanup there. Now, it depends on the angle. This is one we can do. We don't have to go to the calculator at this point. because we know cosine of 2 pi over 3 if we put our brains to it. So we have 20 minus 16 times. Okay, so cosine of 2 pi over 3 says, I want to know what the cosine of pi over 3 is, but in quadrant, where is 2 pi over 3? Quadrant 2. So what is the cosine of pi over 3? 1/2. In quadrant 2 makes it negative 1/2. Okay. What do we know here? Minus 16 times minus 1/2. Well, half of 16 is 8. Half of 16 is 8. A negative times a negative is going to make it plus 8. So we really end up with the square root of 28, if we can do some basic math. Basic math is a little rough.
24.
Now, we could express this as 2 square roots of 7, right? Because 28 is 4 times 7, the square root of 4 is 2, so 2 square root of 7. We also could express this as a decimal. And as a decimal, it's 5 point something. Because I know square root of 28 is bigger than square root of 25.
5.4.
5.29.
I have 5.29 written down.
I was just throwing up random numbers.
Now, here's the deal. Depends on the situation. Depends on what homework asks for. I'm guessing you guys just put square root of 28 in the calculator. Could you have gone up here and put something up here in the calculator? Yeah. We could have put that in the calculator there, and we would have been in the same situation. Okay? Okay. Your homework. Lots of broken up pieces to write down, but it's not as long as it looks, right? Page 484, numbers. 1 through 4, 7 and 8, 11 through 14, 27, 31 to 34, 51, 52, 58, 59, and 60. Now, up there I wrote it as 58 through 60. Whatever. And what I'm going to give you is one little polar graph. It's on a half sheet of paper, and I think, if I recall correctly, it's maybe for 7 and 8. I will have to double check. I can't remember which numbers that you need this piece of graph paper for, but it's just good reference to have, right?
Oh, sure.